All right, we're going to do parts D, E, and F here. The function b of x equals negative 2.6 x squared plus 49x plus 3,994 miles, the number of births from 2000 to 2009. And d of x equals negative 0.6 x squared plus 7x plus 2,412 miles, the number of deaths from 2000 to 2009. Write a function that models the total number of births and deaths from the years 2000 and 2009. So the total, so when you're talking about total, what are you thinking here? The total means you're going to add. So we're going to add those two together. So I'm going to add those two functions together. So I'll put b of x plus d of x. So negative, did not give myself enough room here, plus 49x plus 3,994 plus negative 0.6x squared plus 7x plus 2,412. We combine like terms, add those together, add the x squareds together, the x's together, and the numbers. And remember, when you're adding, the variables, the power of the variables won't change. It's just the coefficients in front of the variables. So negative 2.6 x squared plus negative 0.6 x squared, that'd be negative 3.2. You're down $2.60, and you lose 60 more cents. So now you'd be down $3.20. 49 plus 7, 56x, and then 3,994 plus, we'll go to the calculator there. Okay. 3,994 plus 2,412, 64 or 6,406. So that's my total number. So now I want to use this function to find the total number of deaths, births and deaths in 2003. So 2003, that would mean X is the number of year, or X is the year. All right, and I left out a very important detail here. X is the number of years since 2000. So I'm going to put that here. X number of years since 2000. And that's usually what we do, but I didn't put that in detail in there. That's very important. Use a function for part D to find the total number of births and deaths in the United States from 2003. So in 2003, so I'll put the total, I'll put T. I'll put T of X, T for total, which might be bad because T could also mean time. So I'm going to put T, and I'm going to put T of 3. So I want to find the whenever X is 3. So negative 3.2 times 3 squared plus 56 times 3 plus 6,406. That would equal, so I'll plug that in here. Type that in there. And I get 6,545.20. And so if you're being literal here, you might say that's what the model projects. You might say around 6,545 births and deaths. It might make sense to round there because you wouldn't have a fraction of a birth or a death, but okay. F, does the resultant part E overestimate or underestimate the actual total number of births and deaths in 2003 obtained by the graph? So first off, let's go find what the graph says. So the graph, we have 4,090 births plus 2,448 deaths. Okay. And so this would give me 4,090 plus 2,448. 6,538 is what the model actually projected. Okay, and then that's what actually happened. So this is the actual here, so I'll put actual. And the model gave me this. So this is the model. And so the model overestimates because it has more births and deaths combined than actually happened. And so how many more? 6,545 minus 6,538, and I'm gonna put a rounding around 7. So overestimates by around 7 births and deaths. which is actually, that's a pretty good model though, with these hive numbers, that the model is pretty accurate there because it's not too far off. These two values are pretty close.